Today I'm joined by Alvise Simondetti. He's head of the Arup Explores program. So Alvise, you take the view that COVID-19 will stimulate digital innovation. And to that end, Arup has been freely sharing its thinking on designing with digital fabrication and also holding webinars on the subject. And the report you produce covers various ways we deliver digital fabrication: additive, subtractive, forming, assembling with robots. Are all these routes progressing at a similar pace, or do you see winners and losers in the race to create buildings?
Thank you, Peter. I guess I'm an optimist, and I see all digital fabrication techniques. I'm also in love with an enthusiast and in love with the field, having been working in digital fabrication since 1995. So I can't really spend too much time on losing techniques. I think that there are two areas that I would bet on. And of course, I work in the foresight team in Arup. So we are focusing on the future, but we can't predict the future either. All that we can do is to create plausible alternative futures and then share them with our business colleagues to make them reflect whether their strategy fits those futures. So these two areas, I guess, one is that the techniques, the digital fabrication techniques, should fit within the circular economy. So what do I mean by that? I think I would bet on techniques that lead to the complex assembly of simple and disassembly, of course, of simple components versus the simple assembly of complex components, of which there is quite a lot today. The other part that I think that is going to win, and again, or at least we need to consider, and is very excitingly emerging in the past few years, is augmenting versus replacing humans. So here, the idea behind this is that whereas machines or machine vision is very, very good at perception. It has superhuman perception. It never gets bored. It is very, very precise. The machines are pretty lousy at dexterity. And so we would, this augmented humans is sort of giving you the best of both worlds, the dexterity of the humans and the precision of the machines. I think that augmented humans require a different kind of programming. So being augmented reality, it has to feel right. And this is where we move. Again, I think that winners will be those going forward, will be those techniques that are using the learned algorithms from data, and versus maybe the excruciatingly long list of commands that is controlling a lot of digital fabrication at the moment, and that requires a controlled environment such as a factory. So we are mostly interested and excited about the opportunity to have a digital control of fabrication outside the factory. And that has to be learned. It has to be taken into account of the conditions of the site. And this is more and more relevant today, where we are facing an unprecedented context thanks to COVID, and therefore anything that has been scripted in the past may become actually redundant in a COVID or post-COVID environment. Even in the simplest case of distancing on the social distancing on the construction site.
You see the goal, though, to be the reduction in use of material and reduction in waste while not disrupting traditional construction, rather than the delivery of innovative forms of architecture. Tell me how that works.
Thank you. Let's talk about why we are excited about digital fabrication. So digital fabrication has been around for a long time. This is nothing new. Why are we all of a sudden very excited about it? And why did it take so long? And relatively speaking, it didn't go so far in terms of construction industry. And there are many, I'm sure there are many different ways to look at it. What I'm interested is that is the idea of using digital fabrication to solve some of the greatest challenges of society. And so material resources, so if the entire global south deserves the same conditions as the north, or the developed western developed world, we will certainly run out of resources if we carry on constructing the way that we are doing. So we eventually, before we run out, I guess the price will go up a lot. So the economics of the current construction methods will have to change. And so that is where I guess that's the reason why we are behind this idea of reduction of materials, complex construction without increase in waste during the construction project process that has been the case recently until now. Well, let me give you an example. I don't think a reduction of material and waste is necessarily separated from an innovative form of architecture. So we recently we're working with Norman Foster on the roof of the Kuwait International Airport, the new Kuwait International Airport. And this is in a desertic climate. The terminal is 1.3 kilometer in maximum length, so it's a very large roof. And to have a traditional solution of steel and glass panes would have been unsuitable for the climate. So the design team came up with aspiration to have a concrete roof. And the large concrete roof, a very, very large concrete roof, would be a shell. And a shell is already a very, very efficient structure. Well, the team came up with a digitally fabricated solution where the steel and glass, so where the glass panes of the steel and glass construction were, so to speak, replaced by thin concrete panels. So you have the team calls it the cassettes. You have these cassettes. They are 3 meters by 3 meters that have a digitally computer numerically controlled sides to it, and a concrete that is curved with an adaptable mold, also digitally controlled. So here, each mold is different. There are 48,000 panels, and there is no extra waste because the mold is adaptable to the different geometry. This way led to a roof that it is, I'm told, is half of the material, half of the weight, and therefore, a very small portion, a very big reduction in materials of a shell roof. So this is an incredible performance achieved with digital fabrication, would have not been possible without. Yeah. And here is, I guess you can call this an innovative form of architecture, yet reducing material and waste.
Well, that is particularly interesting because I wrote a book some time ago about the design of Sydney Opera House with Jack Zuntz. And actually, yes, of course, one of the great things that Arup came up with for the design of the roof for the Sydney Opera House was that he used one single radius to deliver all the panels, so you didn't have to vary your molds each time. So we've turned around 360 degrees really in the way you design this sort of shell structure. So that's really interesting.
Yes, I have a presentation around the briefing note document that you referred to, and my first slide is the key message is we want to go from a word of KISS to a word of KICS, where KISS, everyone knows what it means, and KICS is, we substitute the word simple to complex. And this is a complete change in approach. And this is very counterintuitive for many people. And this is what the industry is going through at the moment.
Yeah, so that brings me to my next point, really, because DFMA, or Design for Manufacture and Assembly, which is very much something the government is pushing for a lot of housing delivery, and the building industry generally advocates a sort of standardization. So you suggest that the digital allows much more bespoke design. So is the industry currently going in totally the wrong direction?
No, the FMA is not the wrong direction. I think that it is becoming less and less true, if we can put it that way, is that it is not necessary to simplify the design in order to scale a solution, which is what it used to be in the past. And there is many ways to give evidence on that, but I think the most obvious one is manufacturing. Look at automotive manufacturing. Automotive manufacturing nowadays, whichever way they do it with computer control, it delivers bespoke solutions, and it doesn't delivers at the same scale or bigger scale faster and cheaper than in the past. So that is the biggest evidence. I understand from within the industry, if you look at the Modular Institute in the United States, and this changes from country to country, but I think it's wrong to say that modular systems are cheaper. The study reports a 15% higher price in general than conventional. And I think if you look at the material, I understand the volumetric, and this is not my area of expertise, but I understand the volumetrical steel frames are about 40%, use 40% more steel than a conventional one. And this is simply because, or partly because, the pods need to have a structural stability while they are transported, as well as once they are in situ and they support each other, so to speak. And so this is the reality of, and so there will be what we are saying is that there is important to look at alternative futures, alternative plausible futures, and then as a business, and then make sure that your business has what are the implications for your business in the different settings.
Where can we actually see digital fabrication in operation? Can you point to some buildings where this has been used? Is it still in the lab, or do we have to wait for Norman Foster's airport?
Thank you. I mentioned Kuwait Airport is well under construction. The cassettes are going 9 at the time, and they are installed under less than what was foreseen. You can go to 443 Queen Street in Brisbane. This is a podium with a tower. Arup designed a very complex transfer deck in reinforced concrete. The reinforced concrete is positioned, the complex reinforcement is positioned on site by workers that are using an augmented reality system by Trimble Vision in order to deliver the precision necessary for this complex geometry. You can finally, I guess, you can go to Sagrada Familia. So here we have a project that was sort of got into a trouble. The constructions stopped because of the very highly constrained design challenge, and this was the fact that you had to build a 40% additional structure of all the towers on top of an existing foundation. And so the other constraint was that the Sagrada Familia had already purchased the stone, so you had a constraint in material and a constraint in foundations. And the standard traditional structure of steel frame and stone cladding, which is very common throughout the high-rise industry throughout the world, was just simply not. It was just too heavy for the foundations. So we are used to see post-tension concrete, and what you do is you put a sleeve inside the concrete before you pour it, and then you will place a stainless steel cable inside the sleeve and post-tension it after the curing of the concrete. This obviously is not possible with stone. And so it was actually the computer control that enabled the perforation of the stone in an accurate way, and the perforation of the anchoring. You want the anchoring to be to distribute the post tensioning properly around the stone. And so that precision of construction was achievable only with the digital control, and that solution delivered a post-tension stone solution which was suitable for the existing foundations of the temple. And the other thing that it did, the construction method is divided in panels. There is, and the panels are constructed off-site because there is no more building site left in the center of Barcelona. And so, which is yet another constraint of this project. And in terms of time, the story goes that it took 100 years to build 60% of the church, and now the project is on track to deliver the 40% remaining of the church up in the sky, up to 775 meters from the ground by 2026, which is the anniversary of the death of Gaudi. And this is 10 times or 10x, as they would say in Silicon Valley, improvement.
That's fascinating. Well, hopefully we will be able to travel to Barcelona and have a look at that in the not too distant future. But Alvise, thank you very much indeed. And I think it'd be really interesting to try and redesign the Sydney Opera House actually from Utsen's original drawings, using the equipment you have at the moment, rather than, as I remember, Peter Rice at Arup, it took him 2 weeks to analyze every change that Utsen made to the structure, which of course led to a lot of its delay. So you would also speeded up the delivery of that building too.
I think that's very relevant. I think in a time of COVID, one of the things that a completely digital process of design and fabrication gives you is the agility. We all know that when you adventure for a trip with TomTom, as opposed to using your old-fashioned maps, you can actually make changes along the way, and always get there the fastest, and you're always informed what is the implication of the change. I think this is so important for us because our clients are all asking to change, whichever way it may be. And when you have a digital process, as you said, those changes can be assessed, decided upon, and implemented a lot quicker, which seems to be fundamental for a situation like we are in today. Thank you, Peter.
Thank you very much.